Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the Coding a 2D Game Engine in Java series. Now real quick, before we start this episode, I have to talk about a couple things. First of all, I plan on ending this series very soon. However, due to popular request, I have decided to finish the series off to a point that I think is acceptable. At the beginning of the series, I said you would be able to build Mario with this game engine. We're not at that point yet. So, we will finish Mario, and then once we have Mario finished, I'm going to end this series in favor of the C++ series and shifting the channel towards a more C++ mindset. So, keep in mind, this code is not going to be my best code. The way I would write an engine has changed pretty drastically within the past few months just because of me working on one in C++. However, I can't really translate the C++ into Java because we don't have access to some lower level features that I'd like to use. So for instance, with the scene hierarchy panel, we really won't be able to finish that. So I'm going to sort of streamline the process of finishing this engine. We will finish animations in the next couple episodes. Then we'll add sound in the next couple episodes. And then we'll build Mario using what we have, and we will conclude the series. So towards the next couple episodes, what we're going to be working towards is this. All right, you can see that I've got Mario. We have this question block that's blinking and everything. Everything's working good except for the gizmos, which we'll fix in another episode, okay? You can also see that when we bring in an object, it's highlighted differently. The mouse coordinates are working perfectly. So before I had some issues with the way I was calculating the mouse coordinates in world space and vice versa. So that has been fixed. You can drag and drop multiple objects into the scene. No box select or anything like that. And you can see that sometimes we get duplicates, but I expect you guys to be able to add those features at your leisure after the engine concludes. So this is what we will be working towards in the next couple of episodes. This episode is all about bug fixing. So we're going to fix up the mouse coordinates and several other things that were not working correctly. So in the last episode, we left off with something like this, where we just sort of had some blocks sitting on the screen that kind of moved around like this and stuff. I'm just going to go ahead and delete all this because we will be doing a lot of new stuff, and I don't think it's helpful to have those there right now. Anyways, if I play and stop this, you can see that we've got everything just the way it was working before. And I'm not going to go about solving these bugs in any specific order. I am going to start with the mouse listener because that was one of the biggest bugs. So if we go into our mouse listener class, we can see exactly what the problem is. What I'm going to do to show you sort of how I solve this, because you do need to know how to solve this and everything in order to solve this in the future yourself if you ever want to. First of all, let's remove a bunch of unnecessary junk that is in here. So I'm just going to remove this. I'm going to remove this. We'll keep scroll X. I'm going to get rid of the world DX and DY because we're going to be sort of replacing those with something a little bit better. Screen X, screen Y, I'm just going to, well, I'll leave it for now so that we can see what the problem is and how I was able to spot the problem. But yeah, then I'm going to get rid of this ortho X. Going to get rid of this ortho Y function. Going to get rid of, okay, yeah, so that's all fine. And then I think there might be one more. Nope, that looks good. So then let's just remove these unused variables up here now. And that should be good. So now if we try to run this, we're going to have some problems. And also we will have to remove all of this stuff and all of that stuff. So if we remove all that, hit Shift F10, it's going to say we can't find a bunch of symbols. So we're going to replace this stuff with just temporary placeholders for now. We'll just say get X. Well, we'll do get screen X because we're going to replace that one with a different function too. So this way we can find all these functions again. So we'll replace this just so that we can get it compiling and see what the problem is. And then if we go ahead and in gizmo.java, it looks like we also have some errors. Replace this with screen X and screen Y. In mouse controls, we have some errors, so just replace these two as well, screen X and screen Y. And then in scale gizmo, we also have errors. Once again, screen X, screen Y, translate, same thing. Mouse listener, same thing. Okay, so we have all this stuff. We can get rid of that. Now, if we run this again, we shouldn't get any errors. Oh, we got an error. I missed a couple. Replace that, replace that. Okay, so now we run this, we don't get any errors, that's good. Now, nothing's gonna work right because we just sort of replace these with junk, but it works. So next thing I'm gonna do is Control-Shift-N, go into Level Editor, Scene Initializer. And then I'm gonna go ahead and go into this IamGUI function just so that we have a place where we can print stuff out. And I'm gonna print X plus And then we'll say screen coordinates or mouse listener, sorry, and dot get screen X and duplicate that line. And then we will also do Y. And you will see exactly what the problem is here. So now let's go into mouse listener and we'll take a look at what the problem is. So if we look at calc ortho X and we put in system.out.println right here, current X. Let's take a look. What is this supposed to do? This is supposed to return 0 to 1 if the mouse is over the left side of the game viewport in the right side. Let's see what happens now. So if I hover the mouse over here and then hit Alt F4 to exit, we're getting 0, so that's not bad. But then if we go over here, hover over here, hit Alt F4, yeah, this, oh, okay, so we didn't normalize it. I was like, this is completely wrong. Okay, go down one more line and then put this. And what I'm going to do is instead of, so this is supposed to turn it from a range of -1 to 1, right? So this gets it from 0 to the game viewport size .x, and then this will get it from -1 to 1. So if we go to the right side of the screen, we should get +1, which we get, so that's good. Then if we go to the left side of the screen, we should get -1, which if we look at this, we also get. So that's good. Where's our problem then? That's returning the values correctly, right? Basically, I believe that since we're multiplying like this, we're actually modifying these variables. So what I thought would happen is if we're doing multiply, it would put the result in view projection and not modify any of these variables. Well, that's not actually true. It's modifying everything. And so this is just completely screwing up because every time you call calc ortho X, it gets a new value inside of here. And then it's just modifying state left and right. So we basically just have a problem with it here. Most of this is actually pretty good. I'm just going to change the names of a few things and then we're going to reformat this a little bit. So instead of calling this calc ortho X, because I don't think it's not clear to me what that means, you know, we're going to call this something a little bit easier to understand. So we're going to make a function and call this get world, which will return a 2D coordinate in world coordinates from the mouse, right? This is the mouse listener. So get world is going to get the mouse listener's coordinates in world coordinates. So we're also going to need the current X. You can see that we have current Y here, but we also need current X. So let's go ahead and copy this, which should be good. We'll paste it down here. Now we have current X and current Y. The vector, I'm going to populate with both of these. The vector looks okay. We have X, Y, 0, 1. You need to make sure that W is a 1, otherwise you will get errors. And this current Y value looks okay too, to me. I might be wrong, but we'll revisit that if we need to. Then this is where I'm going to make like the real changes, right? So we have this view projection. I'm just going to get rid of that notion altogether. What we're going to do instead is we're just going to say matrix for F temp equals a new matrix for F. And we're going to use the camera dot get inverse view. Okay, and let's actually name this something a little bit better. Temp is a kind of stupid name. We'll name that inverse view. Then we're going to make a matrix for F. We'll call this inverse projection equals new matrix for F camera dot get inverse projection. Okay, so what we're doing here is we're basically ensuring we will not modify the camera's actual matrices because we're wrapping it. We're creating a completely new object. So this is good. This will make sure that we don't do something stupid again, or I don't do something stupid again. Okay, then we're just going to do all the multiplication right here. So we're going to say inverse view dot multiply inverse projection, and then we're going to multiply that by temp, which should translate this current X, current Y into world coordinates. Then we're simply going to return new vector 2F temp.x temp.y. Now let's go ahead and change the names of these to get world Y, and instead of having all this duplicate code, we can just say return get world.y. And we need to return a float. We can't return void there. Then we'll do the same thing for this, except we'll call this get world X. And then right here, we will simply say return get world.x. All right, so that should be good for the world coordinates, and screen coordinates actually look good to me. I will simplify things a little bit more. We'll just make a static vector 2F get screen and do something similar to what we did down there. So we'll copy that. We'll copy just this Y portion right here. And then we will say return new vector 2F current X, current Y, which is good. Then right here, we can just say return get screen .x, and then right here we can say return get screen .x. This should be .y, that should be .x, and that will fix it for now. Real quick, I'm just going to change the names of these functions just so that we can get all those errors and correct them appropriately, okay? So inside of editor update in editor camera, when we are doing this, we do want the world coordinates, not screen coordinates. So we'll say get world. Actually, we could just say new vector f mouse listener.getWorld. Simplify this even more. And then we'll do the same thing here. This should be world coordinates, so we'll say get world. And actually, we don't even need to do this. We can just do this because we are returning a new vector out of the mouse listener already. All right, that should correct the editor camera. Then let's go into Gizmo. I believe this is also looking for world coordinates, so we will do the same thing here. We'll say mouse listener.getWorld, which should correct that. And then it looks like we have one more error in here inside of the gizmos. So we'll say mouse listener.getWorld, and we should be good there as well. Let's go on. We have the properties window. Okay, so this is where we actually want screen coordinates, right? Because inside the properties window, this is basically checking which pixel we're clicking on, right? Because we're picking the frame buffer texture. So we want screen coordinates, not world coordinates. So we will say mouse listener.getScreen X. So this will actually correct itself once we rename those functions. Mouse controls, let's go into here. We're going to want this in world coordinates. And we'll do get world X and get world Y. Oh, and it looks like we made those private inside the mouse listener. Or maybe you didn't, but I did. So let's go ahead and we will make these public, not private. So just rename those and we should be good. If we go back here, these errors disappear. Inside of scale-gizmo.java, we will change this to get world X. Most of these are just going to be world coordinates, but it's good to double check all of them just in case, like that one we had where we wanted screen coordinates. Once again, world X here inside of translate-gizmo.java. And then lastly, inside of mouse listener, we will go ahead and remove those. Okay. And then let's go ahead and also change the name of our screen coordinates back to get screen X and screen Y. Then if we run this, we should get no problems. We get no problems. Right now, the object is not clamping to the right place, right? And why is that? Well, if you remember, we changed our code so that it centers around the origin of the object, not from the bottom left corner anymore. So it's kind of just placing it in the wrong position. So this is actually pretty easy to fix. If we just go into our mouse controls, I believe, we'll be changing quite a bit of code here. We'll take it one step at a time though. So we want to get that to the correct place. Right now it is kind of off kilter. So we can just add in half the grid width and half the grid height to wherever the object is, and that should correct part of this. So if we just go ahead and wrap this, we'll do a parenthesis here, go to the end of the line, parenthesis here, and then we'll say plus settings dot grid width over 2. Then we will do something similar for the height. So this will basically just make sure that we are in the correct square. We're not like halfway between two squares, right? So if we do that and then go back into here, we should see that it should be in one square, which it is, almost. So looks like the Y position is off. We will explore why that is. I think I might know, but we'll check it out. Oh, it's because I forgot to do over 2. So that was very simple. Now we go back into here, and then if we drag, okay, yeah, we drag and it is in the right place, except it's 1 off in the X, right? It's 1 to the right. So what we can do to fix that is, instead of doing anything, this should be math.floor. If this isn't math.floor, then we won't be rounding consistently and we'll actually end up changing. So if we're on the left side of 0, then this will do one thing. And if we're on the right side of 0, it'll do a different thing. So if we change that to floor, we should fix, yep, the X coordinates are now in the right place. And the Y coordinates are not. If you notice, it's like halfway between it. And why is that? Well, there's something weird going on, right? Let's go ahead and just first of all check one thing, right? If we go ahead and print out mouse listener.get world Y, and I'm showing you this because this is sort of how I debugged, right? And then if we go into our scene, just to make sure we know where the camera is located in the world, let's reposition the scene to 0, 0. So the bottom should be 0. The left side of our screen should be 0. And if we put our cursor right at the bottom there, we should see 0. So let's just make sure that is true. Well, we'll see 0 if I think we're holding an object. Yeah, so let's move this out of here actually, just so that we can try and see what's going on. So we'll put that right there. Then if we hold our cursor right at the bottom of the screen, we get 0.0. So that's good. We are hitting the right location there. If we hold it at the top of the screen, we should get 3 because our projection size is 3. Yep, we get 3. That's good. Okay, well, what's the next thing we could check? Well, we should check this line right here. This should be at 0.25 because that's the settings I have for my grid width and grid height. Well, what is this? What? This is 0.32. That's not right. Okay. And why is that not right? Well, it took me quite a while to figure this out, and I think I finally solved it. It's something inside of not IMGUI layer, but our game view window, right? Because we're using this to sort of figure out where certain coordinates should be and everything. Now, I made a lot of changes in here, so we're just going to go through and make all of the same changes, and hopefully it will fix our problem. So first of all, what I end up doing is I don't do this first. Instead, first I set the cursor position to IMGUI.get cursor pose X, IMGUI.get cursor pose Y. And technically, this does nothing. So if we finish this, we should be able to remove this line and it should function exactly the same, hopefully. If it doesn't, then something's weird. Okay. Then we do this whole window size and window pose and everything. And then we're going to go ahead and do IMGUI.set cursor pose, window pose.x, window pose.y. And let's go into get largest size for viewport. The changes I made in here was I just removed the scrolling. We shouldn't have to worry about scrolling because we're setting the size of the contents explicitly and we're only setting it to the maximum available size. So we can remove the scrolling safely and not worry about that. We'll do the same thing down here for get centered position for viewport. So we'll just scroll down, remove that as well. Then inside of this position right here, I had to add 10 to the X coordinates to get it to actually work right. Not sure why. Let's also remove the scroll from here. We don't really need that. And we're also going to remove this whole top left thing. And instead of setting the left X, bottom Y, all that to that variable, we're just going to set it to window pose, right? Because that is what it should be. So if we just do all this and then add 10 here as well, to correct for that offset that I'm not sure why I'm getting, but 10 seems to be the magic number. If it doesn't work on your resolution, then maybe this is some IMGUI setting that we need to figure out. Then inside of here, we're just going to set it to window pose.x plus 10 and window size.x, window size.y should be good. Let's go ahead and run this and see if this fixes it. I honestly can't remember what change I made that fixed this. So, okay, yeah, you see it's working now. Our Y coordinates are in the right place and it's working. So I'm not sure which one of those changes specifically fixed that bug, but one of them did. It was weird because I was thrown off because I was just checking the bottom and the top. And I was like, oh, those work. So of course everything in the middle is going to work, but you know, it's not. So yeah. Anyways, that is that corrected. Let's go ahead and implement that dragging feature. You can see that something weird there just happened because that did not work right. So let's go ahead. Stop printing out this value wherever we're printing that out. So inside of mouse controls, we'll just remove that print line and then we're going to do some more stuff in here. So first thing we're going to do is we're going to add a debounce time in here. So right now, if you click, you could place multiple objects on accident. We don't want to do that. So we'll go ahead. Technically you can't because it'll automatically just click onto the object, but we're going to fix that too. We'll go ahead and add a private float debounce time and we'll set that to 0.05f. And then we're going to say private float debounce equals debounce time. So this will be sort of like our reset value, right? Then we're going to go here and we'll say if holding object is not null and debounce is less than or equal to 0. And we'll just subtract dt from debounce right here. This way we just can hold and click without worrying about placing multiple objects too much. We'll just say debounce equals debounce time in here. And then I'm going to add in one more key combo that's kind of useful. If mouse listener dot mouse button down, GLFW escape. Then we're going to go ahead and say holding object dot destroy. And we're going to say holding object equals null. So this way we just destroy the object and it is no longer holding it. So if we go back, we should see that if we're holding an object and then you hit escape, and the problem is I did mouse button down. Escape is not a mouse button, it's a key button. So let's do key listener is key pressed. Redo this and we should get the correct value this time. So if we hit escape, you can see that the object destroys and it's kind of out of sight, out of mind. Now I'm going to modify our place function just a little bit. It's going to do a little bit more than just placing the object by setting it to null. That way we can hold down and place multiple objects. So what we'll do is we'll say game object, new obj equals this dot holding object dot copy. So we'll copy the object that we're holding. Then we'll say new object dot get component sprite render dot class dot set color new vector for f1111. And the reason we're doing this is because we are going to set the transparency to a little bit lower color when we pick up an object in just a minute. So we'll do that. And that means we will have to reset the color here. So this is basically just setting the color of whatever object we just copied to white. And then we can go ahead and say window.getScene.add game object to scene, new obj, which should add the object to the scene. Now, if we go ahead and run this, you can see that we can click and drag, and it works like you would expect. Then if you hit escape, it removes it, but you will notice that if you delete some of these, they were placed down multiple times. And you can mess around with the debounce time and adjust it to something that you like, just to make sure you don't place down too many copies. Let's go ahead and make it transparent when you're holding it so you know that you're holding an object. So right here, we'll say this dot holding object after we set it, dot get component, sprite render, dot class, dot set color, and we'll just say new vector for f, 0.8, 0.8, 0.8, 0.8. So we'll just set it to a white color with some transparency just to make it a little bit see-through and easier to tell that that is what we're holding. And let's actually set this to 0.5. Then we're going to go ahead and say this dot holding object dot add component new non-pickable. That way we don't click on it, because right now what will happen is if we place an object, so you can see that it's transparent first of all. Then if we place it, you can see that immediately we select it, and notice that we're selecting the object we're holding, right? So if I click, we're not selecting the object we just placed, we're selecting the object that's like in the mouse cursor, and that's really annoying. We don't want to do that. So if we just make sure to add the non-pickable class, that will make sure that you can't actually click on that object. And if we add it again, you'll see that we don't get that annoying glitch. And then we can go ahead and just click and drag. You'll notice our scene hierarchy window over here just adds a ton of them, and they all get added to the scene. We just want to make sure that we also remove the non-pickable component once we finish with this. So we'll say new object. So after we copy it, we'll just remove the non-pickable class. That way you can once again select it once it's actually in the scene, right? So now we should be able to click, then we can select them and we can do what we want with them. The gizmos are messed up. We'll work on that in the future. One last bug that we're going to fix in here real quick is if you notice, if we click down here, we're holding this object. Then if we click down here, we select a new object. But what just happened? Well, we accidentally placed this object, and it's a ghost object because it's not really added to the scene. You can't click on it. You can't delete it. It's horrible and annoying. So let's fix that. We can just go up here, and then when we pick up the object, we'll say if this dot holding object is not null, this dot holding object dot destroy. Very simple. That will make sure that if we're holding an object like we are right now, and then we click a different object, we can start placing this object, and we don't place a duplicate somewhere that we don't want to. So that solves that problem very easily. Now let's go to the properties window and add one line of code that will make our lives a lot nicer too. So right now, if we were to pick up an object, start dragging and placing, you'll notice that we can start selecting objects. You can see the gizmos pop up real quick and then throw the object way down. That's annoying. We don't want to do that. So in the properties window, this is where we basically check and see if we're clicking on an object. We can simply just say if not mouse listener dot is dragging and all that other stuff. That way, if we're dragging the mouse, we won't end up selecting an object, right? And now we can place objects and it doesn't select them till we actually click on them. That is also very nice, right? Now we can place a lot of objects and not have to worry about it getting sort of stuck in the scene. Real quickly, let's just go into Sprite Render because there was some code that I've had in here for a while. I'm just going to remove that because there's no sense in having it. I'm going to make this a little bit easier to read. And also this says color pickier. This should be a color picker. So I'll fix that real quick. Don't know if you had the same mistake or not. Okay, and I think that is it for this episode. We just fixed up some bugs, made the workflow a little bit nicer. Now you can add multiple objects, which is nice, and then just sort of fill in the gaps here. Afterwards, the only downside is you do get duplicate objects. You could find a workaround for this, but I'm not going to spend the time to do that because, as I said, I just want to get to this to a point where we can build Mario, and then I'm going to finish this series up. But I hope you guys enjoyed this. If you did, please hit like and subscribe, and stay tuned for the next episode where we will be implementing these animations, right? I also didn't show you. If you click on the animations, you can click the state machine up here. You can change individual frame times and the title of this animation state. So right now Mario only has one state, which is run, but we could add a jump state, a swim state, anything else, and then triggers to trigger him from one to the other. So we'll talk about all that, but if I move this up, you'll notice that he lags on the first frame, and then the next two frames go a little bit faster. And then if I move this to like 0.1, then you'll notice that the first frame goes very quickly. So that's interesting, and it's useful because for this question block, we actually do want that, right? We want the first frame to last a little bit longer and then the next two frames to be a little bit slower. So we'll talk about all that in the next episode. I'll see you guys then.